Forward, here we go.
It's gonna be all four.
This is going to be I have a thought process going. Okay, we are in 4-4. Okay. And I love you all. Here we go.
All right.
Okay, so you guys know at the top of your unit circle how it has a positive thing? Well, here's where it comes from. If you don't recall from last year, certain quadrants are positive for certain cosine, sines, or whatever, the trig functions, right? I have a little saying. Do you remember my saying from last year?
You kind of have a lot of sayings.
Oh, no, that's it. All students take calculus. That's my goal, is all you guys take calculus. Okay. Speaking of which, I'm going to pause. All, and that stood for all of them are positive. All are positive. Whoa. And the reason being is because this coordinate's a plus plus, right? It doesn't matter. I said all are positive. Okay. Now, that means all trig functions are positive in the first quadrant. Okay. Now, if I'm in S, what do you guys think that means?
Sum.
Okay. That means sine is positive. Oops, that's the wrong kind of sine. Sorry.
Yeah.
Anybody tell me why sine is positive?
The y value.
The y value, look at the y coordinate, it is positive, right? And tangent is y over x, and so notice it's a positive over a negative, which is a negative. Yes, sir? Cosecant, well, sine goes with cosecant, right? So mainly we're talking about the reciprocals as well. Does that make sense to you guys? Okay, tangent. Okay, with that being tangent, I would say negative, negative. And that's because of there, so this is tangent. Because notice y over x is a negative over a negative, which is positive. Does everybody understand that? Okay. And then last but not least, this is cosine. Because notice you have a plus, negative, and cosine's your x value, right? Is everybody understanding why each quadrant is who they are? So where is sine positive? Who else? He's in 1 as well, right? 1 and 2. They're positive in 2 sections. Okay, so sine is positive in 1 and 2, tangent is positive in 1 and 3, and cosine is positive in 1 and 4. Where is sine negative? 3 and 4. Does that make sense? How you got to look at, say, where they're going to be positive, where they're going to be negative? Does that make sense with you? Okay, you guys okay with that? Okay, with that being said, I would like you to tell me I want you to find all 6 trig functions if tangent of theta is negative 5/4, but cosine of theta is greater than 0. Why did they throw that in there as well? Because once again, let's think about this. I just barely told you that tangent is positive in 2 quadrants and it's negative in 2 quadrants, right? But, so that gives me 2 quadrants. What quadrant is tangent negative in? Let's tell me where it's negative. He's positive in 3, so he's negative in 2 and 4. Where is cosine positive?
4 and
1 and 4, right? Sam, are you okay? I just wrote that down. That was given to us, but do you understand where they're negative at or anything? Okay. Once again, all students take calculus, so tangent's positive in here, so therefore he's negative here. Hence 2 and 4. You okay with that? Okay, cosine is positive right here, so that's 1 and 4. Where do they share? 4. So therefore this angle is in quadrant 4. Does everybody understand that? Yes, ma'am.
So are you thinking of positive at both of them?
Nope, he's negative.
Oh.
So tangent's negative, so that's why I gave you 2 and 4. Okay? Cosine's positive, that's why I was in 1 and 4. Does that make sense to everybody? Does everybody understand where you're going to find out where they go? Okay? Now we draw a triangle. Where does the triangle always go back? To the y-axis or the x-axis? Always coming back to the x-axis, correct? Okay, so I'm going to put my theta here. Tangent was opposite, so he's 5, he's 4. But who's negative? Oh, excuse me, he's 4. Apologize for that. Who's the negative guy? Why is the 5 the negative guy?
He's going down.
He's going down. Does everybody understand why he is the negative? Not just because it's up on top, because I could have 5 over negative 4, couldn't I? Right? Does that make sense? Mitch, you okay? So we do good old Pythagoras. This guy right here then will be square root of 41, because this is 16 plus 25, which is 41, and we can't break him down. And it won't be negative because it's a distance, it's a radius. Okay, can we find all 6 trig functions now? All right, so let's go with sine. Sine of theta, you're here. Opposite over hypotenuse. Negative 5 over root 41. So therefore that is negative 5 root 41 over 41. Because I rationalized my denominator. Then I like to go to cosecant. Why do I like to go to cosecant? It's just the reciprocal of this guy, right? So negative root 41 over 5. Is everybody there with me? Cosine, standing here, is 4 over root 41, which is 4 root 41 over 41. Secant of theta is root 41 over 4. And they already told us what tangent was. What was tangent? Negative 5 fourths, and so therefore cotangent is negative 4 fifths. You guys see how I went through that process? Pretty simple. We okay? That was example 1. Aren't I so proud of myself? It took me a little while though. Well, I didn't do it normally. Okay, so now I would like us when cosine of theta, we're going to switch this up. Negative 2 fifths, but sine of theta is less than 0. I'd like you to once again find the 6 trig functions. Maybe I'll just ask, I don't want to spend all that time maybe, so I'll just ask you to find sine, cotangent, and secant. How about that? Is that fair?
Is that a 3 or a 5?
That is a negative 2 fifths, my lady. I will change that just for you. Chink. Does that help you out, Shelb?
Yeah.
Anybody else going to MATC today besides Shelb? Do you need to leave at 11ish too?
No, I don't.
Okay, you're right. I just wanted to make sure. Okay, so first off, we need to ask ourselves, Miss Brighton, which quadrant is cosine negative in? I'll let her try for me.
Is it in quadrant
And who else?
2? In quadrant 3?
Yep, 2 and 3. Does everybody understand why 2 and 3? Notice all students take calculus. So cosine is positive here, so therefore he's negative here, right? Does that make sense? Okay, where is sine less than 0? Well, he's positive here, so he is negative here, right? So where does he share? Hi, sir. I'm doing very well. Thank you. So they share at quadrant 3. So I'm going to be drawing my triangle in quadrant 3, right? Okay. So I'm down here. Cosine, okay, my answer at cosine, notice, is adjacent and hypotenuse. Who's the negative, the 2 or the 5? The 2 is, because notice we're over 2, right? Notice we're also down, so this value is also going to be negative as well. Does that make sense to everybody? Due to good old Pythagoras, I got 25 equals 4 plus b squared. So b equals square root of 21. So this is negative square root of 21. Yes, ma'am.
I don't get why sine in 3 is less than 0.
Okay. Well, what is things less than 0? So sine's positive in the all, because they're all positive here. and sine is net positive here in quadrant 2. So where is he negative? Isn't sine the y value? And in this quadrant, isn't your y value negative? Does that make sense to you? Okay, you okay now?
Yeah.
Okay. So now you just come over here and I want to find the sine of that angle. Is negative root 21 over 5. The secant, we didn't even need to do anything because that's just the reciprocal of cosine, right? So that's just negative 5/2. You see how we're just going through this? Are we okay? As soon as we build the triangle as the 6 trig functions, giving anybody problem, like hopefully you understand those now, right?
Right.
Yes, sir?
Yeah, I kind of felt like I'm saying
Okay, so adjacent, what does adjacent mean? If me and you are standing adjacent to each other, what does that mean? Okay, so next to. So here's my angle. Which sides are next to? This guy and this guy. So this side already has a name. What's his name? Because he's opposite of the 90, right? So therefore this is the adjacent. And then opposite is away from, right?
Okay.
Are you okay with that now?
Yeah.
Okay. Anything I can help you with? That's good? Okay. And then we already did secant, and then cotangent of theta is, remember, tangent is opposite over adjacent, so therefore cotangent is adjacent over opposite, right? So therefore that's negative 2 over negative root 21. We go ahead and do what? Get the negatives and then times root 21 top and bottom. So that is 2 root 21 over 21. Was that good? We feeling comfy? You see the thought process through it? First off, find out where they share, correct? Okay. All right, next one. Notice I want our answer, theta, to be between 360 and 0 in degrees, and I want our answer to be theta in radians as well, okay? So, I want you to say, okay, if I said, where is sine of theta, square root of 3 over 2? So the first thing I want you to say to yourself is, look at that, sine is positive. Where should my angles come from? Because sine is positive. 1 and 2. I should have an angle out of quadrant 1 and quadrant 2. Does everybody understand that? Because there's 2 places that sine are root 3 over 2, isn't it? Does that make sense? 1 in quadrant 1, 1 in quadrant 2. Everybody there? Now this is to be honest, this is where I want you to think. What are first off my coordinates on the unit circle? Well, I have root 3 over 2 comma half, that's at 30 degrees. I have root 2 over 2, root 2 over 2, that's at 45. And then my last one, a half was 3 over 2, right? Notice assign the x or assign the y? The y. So we look, is it this guy? Nope. Is it this guy? Is it this guy? So that's 60 degrees. So that's our coordinate 1. But notice, we could use symmetry, right? And we go into quadrant 2 now, so therefore if this angle was 60 degrees, what's this angle? 60 as well, so what's this angle? It's 180 cut back 60, right? Does that make sense to you?
Yeah.
Okay, so therefore that is 120. Is that my answer, 60 and 120? What else do I want? Them in radians. Okay, what is 60 degrees in radians? 5/3, and notice if I double that, I get 2 5/3.
So all the greater than, less than stuff means.
I want my angles, every angle between basically 0 and 360 and 0 and 2 5. Okay. No,
You want us writing it a certain way?
you could just say theta equals 60 degrees, 120 degrees, and then just put it below it as well.
That's how you want it.
Yeah. A little bit neater than what I'm writing, right? A little bit more organized. Me neat. Did I ever go over a homework question? How many of you guys kicked butt on the old mountain one? I'm just double winking here. Was there a fight? Did I ever cite a firefighter one? No. Ooh, we might be doing that, or the or the lifeguard one, or the tower of fires. Oh. Onward! Whoa, I like this. Okay. Tangent of theta. I don't know if that's in this one, but we're doing it anyway. Tangent of theta is negative 12 over 13. I would like you to tell me about what's, once again, our theta being between these guys, to find that angle. Tell me what angle gives us that. So first off, I want to say, where is the answer going to come from? Where is tangent negative? Quadrant 2 and 4. Is everybody there with me? Yes, no, maybe so. Okay, so, once again, what I do, ladies and gentlemen, is I want to find the angle. Does anybody remember how to find the angle? You use the arc tangent. I will never use the cosine to the negative 1. I will never say that, but please understand the arc tangent or arc sine or arc whatever is equivalent to this button on your calculator. Why will I not use that? Some people believe that looks just like cotangent. I don't want you to get confused. Okay? Does that make sense? Does anybody, from last year, anytime you take the arc tangent or the inverse tangent, okay, does anybody remember what happens? He gets rid of it and you are left with theta over here. But what you do to one side, you gotta do to the other. So ladies and gentlemen, make sure you're in degree mode on your calculator. Okay? Degree mode on your calculator. And we are gonna go ahead and find the arc tangent of negative 12, 13. So once again, I go to mode. Okay, I'm in degrees. Arc tangent is, for me, it's the blue one above tangent, right? Of negative 12 divided by 13. Close my parentheses. Negative 42.7, we'll just go 42.71. Okay? Negative 42.71. So theta, it came out to be negative 42.71. Is that angle acceptable?
No,
Why?
it's a negative.
It's not within my restrictions of being between 0 and 360, huh? But don't we know 42, negative 42 point something's right here somewhere? Can't we find its coterminal angle? How do we do that? Add 360. Add 360 to that sucker. 9. That's our quadrant 4 angle. Isn't that in quadrant 4? It is. Now notice, this will tell us then this 42.71 is called our what? You guys remember from a couple days ago? Our reference angle, huh? So therefore now I can go up into quadrant 2 and say, oh, well if that angle's 42.1, what's this angle? 42.71. So now I got to go 180 cut back that answer, right? Everybody do that in your calculator, please. 180 cut back 42.71. You want me to help you there, Sabrina? I saw you looking. You sure? You have lovely pink on as well. Scarf, it counts. So 180 cut back that, does everybody see how it is? 137.29. And notice, ladies and gentlemen, those are my angles that make that one. Yes, my lady.
Can you use a reference?
You want me to show you just what reference angles are in general? So give me an angle. I don't care. 45. Give me something better than 45. That's not on the inner circle.
27.
27 degrees. Okay. So that's easy. This 27 degrees is there, right? Our reference angle would be 27. Well, let's say I said 127. What is your reference angle with 127? Well, this right here is 127 degrees, right? But what's this angle? 53. That is considered your reference angle.
How'd you get back to that?
So therefore on ours up here, we found out that this angle was 42.71 because it was negative, right? So therefore, what's this angle? 360 cut back that, which was the 317.29, right? Well, we also know there's always two places that have the same value because of reflections and so forth, right? So then we use the reference angle and say, oh, tangent's also negative over here, right? So then I use that same reference angle and say, oh, that's 180 cut back to 42.71, which is 137. Does everybody understand the reference angle idea? Should we try one more of those? Let's do it one more. And what time do I get out here? 11:00 what? 9. Okay. I think I'm okay to do one more. Okay. So, I want you to tell me where cosine of theta is negative 3/5. Same thing. I want theta to be between 360 degrees and 0 degrees. Are you freaking reading a damn book right now? I will kick you in the shin. I love you though, but where should my answer be in? That's my first question I ask myself. Where should my answer come from? 2 and 3, right? Why? Because that's where cosine is negative. Does everybody understand that? Okay, so cosine is negative in quadrant 2, so I should have an answer there, and I should have an answer in quadrant 3. Does everybody understand that? Okay? You good? You tired? Friday? Leg wrestle?
I'm down for that.
Didn't I already leg wrestle you earlier?
We tied.
When?
Last year.
I've never tied anyone.
We tied last year.
That's bull. You're a fibber.
I'm not.
What are we going to take? Are we going to take the arc tangent?
The arc.
Arc cosine. Once again, I do not write that other one. You will never see me write that one. Sorry if there's other teacher wrote it. I will not. You can as long as you understand it is not secant. Okay? Please understand it is not secant.
What would be the difference between that?
See, okay, so that's why I don't like that notation. Okay? I do not like cosine of -1 because that means 1 over cosine if we're talking about exponent. This also means inverse, right? How do you get rid of a cosine? You take the inverse, which is an arc cosine, to get rid of it so you can find an angle. Now, if I'm talking about its multiplicative inverse, these are correct. So it's all about, that's why I don't like it. Okay, and I was always taught arc cosine so that you wouldn't get those confused. Okay? So whenever you look for an angle, it's arc cosine. If you're trying to get rid, like for example, if I had sine of theta times cosine of theta equals 3 over secant or something, we'll get to these later, I could times by the cosecant, which is 1 over sine, and they would get rid of those completely. Does that make sense? What you do to one side and you do to the other. We'll get to those. But it's more algebra based. Okay? Plug this in your calculator. Arc cosine of -3/5. What'd you get?
6.87.
And that is in quadrant 120. We're going to round to the second. 126 point. Just
87.
87. So 87. Okay. Did they give me a reference angle this time? They gave us the angle, didn't they? Okay, and I'll explain that when we get to graphing why they do that on our calculator in just a second. Right now we're not. So this is, notice 126 right here, right? 126.87. Do I have to find my reference angle? I do. Why? Because I still need to know my quadrant down here. So notice I need to find this area for this angle so I can find that angle and then I can find the angle in general, right? One more time. Let me say that one more time because I think I've massacred that. Okay, I need to find the reference angle so that therefore I can plug it in here to then use that reference angle to find the other angle in quadrant 3. Does that make sense? Yes, sir.
How come you know what this one is, reference and the other one?
What does reference angles always have to be? Less than 90, huh? Is this guy less than 90? So he's just a flat out angle. Does that make sense?
Isn't there another one besides representative?
Complementary. So that would be these two reference angles with 180 are supplementary. So anyway, going back,
Sorry.
no, you're good. It's going to be 53.13, right? Okay, so this is 53.13. That's my reference angle. Is that my answer up here at all? No, that just helps us by putting this guy down here as well, 53.13. So, can somebody tell me what this angle is from there to there? 233.13 would be my other angle. And now notice, guys, plug that in. This is, by the way, 0.6, right? Negative 0.6. Plug this in your calculator. Plug in cosine of 126.87. Now, we cut it off, right? So is it going to be exact? Is it going to be exactly 0.6? No, because we cut it off, didn't we? Right? So somebody plug this in. Cosine of 126.87. What'd you get? Negative what? 0.600, but we're so close that it looks like that, right? Okay, then plug in cosine of 233.13. Negative 0.6, blah, 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 right? And it should, because those guys have the same reference angle, so therefore they get the same cosine and the same sine if they have the same reference angle. Okay? Is everybody there with me? Understand kind of what our goal is today? I think we're almost there. Where did I leave my notes? This is why I don't ever have notes. I leave them everywhere.
Maybe you got like a binder.
Huh? You need to have a binder? That's too organized.
I didn't say that.
Who's that? Oh, Lizzie?
Like looking at me, I was like, I didn't.
Lizzie. All right. Find tangent of theta if sine of theta is negative 5/13 in quadrant 3. So did they already tell us where we're at? What quadrant are we in? We are in 3, so we don't have to understand where it's at. We just go where we're told, right? We're going to quadrant 3. Boom, boom, right triangle, okay, theta. Pachiga. Okay, then I say to myself, I say sine is what? Opposite over, so if I'm standing here, who's my opposite? The 5 would be. Is he positive or negative? He's negative because we're down, huh? And then what's this guy right here? 13. Good old Pythagoras comes out, and this is one of our special one of our nice Pythagorean triples. Negative 5, what, and 13. Does anybody know? The Pythagorean triple. You buggers. I love you though. So that's 169. It is 12. 25 plus b squared. Subtract that b squared is 144. Can you now see that it's 12?
Yep.
So he's 12. But because he's left, what is he as well? Negative. So therefore, now we have the triangle. So now I can find any 6 trig functions, can't I? Which one are they specifically asking for? Tangent. So I say tangent of theta is standing here, opposite over adjacent. Would I ever like you guys to leave it as negative 5 over negative 12? 5/12. Are we cruising along singing our song?
Yep.
We're almost done, guys. I think I got one more. Ooh. Bow, chicka, wow, wow.
I like this one.
Sine of theta. Find that if cotangent of theta is negative 4/3 in quadrant 4. I'm going to push. Okay, so I'm going to start my triangle. I know cotangent is adjacent over opposite, don't I? That is what cotangent is. Because that's cotangent, my adjacent is 4, he is negative 3. Does everybody understand why the 4 goes up on top and he's not negative? Why is he not negative? Because he's the x value, and x value in that quadrant is positive, correct? Okay, and then we get good old Pythagoras, and this comes out to be 5, right? Okay, huh? It's a 3, 4, 5 triangle. Then I say, okay, find the sine of theta. We all know the sine of theta is opposite over hypotenuse, so that's negative 3 over 5. Ladies and gentlemen, we have 4-4, 3,
5, 7.
5, 7,
11 to 24,
11 through 24, all.
29
to 85, whatever you are. And 89.
There you go, ladies and gentlemen. I think we had a great day today. Not too shabby. Test, review next week, okay? All right, guys.